Hello everyone, Saidu here. Welcome to another CCNA Cyber Ops Lab. In this video, I'll be talking about certificate authority. So the concept of certificate authority and the HTTPS was introduced back in 1994 by Netscape to provide security to the web, which is still in use today. So basically, the HTTPS relies on a third-party entity for validation, known as Certification Authority or CA for short. What this third-party entity does is to verify if a domain name really belongs to the organization claiming its ownership. And once the verification checks, the CA creates a digital signed certificate containing an information about the organization, including its public key. And the entire system is based on the fact that web browsers and operating systems ship with a list of CAs they trust. So basically what this means is that any certificate signed by any of the CAs in the list will be seen by the browser as legitimate and be automatically trusted. Now let me show you some of the trusted CAs on my system. So I'll be using Firefox as my web browser. You can use anything, and the step in checking out these trusted certificate authorities shouldn't be a problem. Now from the Firefox web browser here, I'll click on the menu, which is located on the far right of the Firefox window. Then after clicking the menu, I will click down on the preference and then go to the privacy and security. Now I'll scroll down to the security section and I'll click on view certificates. Now this window shows the certificates and certification authority trusted by my web browser, which is Firefox in this case. Now another thing that I'd like to show you is how to check the fingerprint of a certificate. But first, what are the fingerprints? So the simplest definition of fingerprint is a hash calculated against the certificate. And this is very important because it allows for a quick way to verify if any information inside the certificate has been tampered with. So the certification authority that signed the certificate usually calculate the certificate fingerprint. And after it has been computed, the certification authority includes it in the certificate itself. So the fingerprint can be easily displayed when viewing the certificate. Also, I'll be using this three-pipe command to fetch the fingerprint for cisco.com. The command includes OpenSSL to connect to cisco.com on port 443, which is the HTTPS. And it will request the certificate and store it in a text file. And I will name this text file cisco.pen. So the command is actually long, so I will have it on my screen here for easy access. So after entering all this command, I will hit enter from my keyboard. Right at the bottom, you will see done, and the command has been executed successfully. Now, after saving that file, I can easily cut it out to see the content of the certificate. So I will use the command cut followed by the text file I saved, which is cisco.pen. So you can see that this is the certificate. This is the content of the certificate. This is where it begins and this is where it ends. And because I already have the certificate saved as a text file, which is the cisco.pen, I can easily get the fingerprint of that certificate. I can do that by using the command OpenSSL space x509 space dash n no out space dash in to provide the input, which is cisco.pen space dash fingerprint, and then the hashing algorithm, which is SHA-1 in this case. So after hitting enter from my keyboard, this is the fingerprint of that particular site. So something to note is that the fingerprint value may be different for some reason. First, you may be using a different operating system than the Cyber Ops workstation which I am using now. And secondly is maybe the certificate has been changed. Alright guys, that is the end of this tutorial. I hope you learned something from this and I will see you in the next one. Thanks.